Can you confirm if my audio is clear? Hello. Am I audible? Okay. What about my screen? Is it visible? My screen is visible, right? Yes, no. Hello. My screen is visible? Okay, then let's continue. Okay, we have completed the topic on top of Java operators. So all the operators has been completed. And yesterday we were discussing about the ternary operator. And before even discussing about the ternary operator, we have discussed about this relational operator, and we have also covered the ternary operator and the short circuit operators. Right? I hope the concepts are clear and good. So today the topic is going to be typecasting in Java. Typecasting in Java. Right? So this concept is little tricky. You must pay some attention. So when I say typecasting, it is like converting one data type to another data type. I will keep the definition very simple. So I can say that the process of converting the one data type to another data type. So data type. When I say data type, we have again the data types can be categorized into two types. One is primitive data types, and the second one is user-defined data types. Let me write those here. There are types of Java data types. One is primitive data type. Second one is user defined data type. Right? So today we will understand the primitive data type conversion, right? And again, under the primitive data types, we have it is subcategorized into 8 types. We know that already. Examples: integer, float, long, byte, double, and so on. Right? So to understand this user-defined data type, we need to understand the OOPS concepts. OOPS concepts, and also we need to understand the concept of polymorphism, a kind of concept in the Java OOPS, and we have a concept called inheritance and interfaces. Right? So I am going to postpone this, the type 2. I'm going to postpone this in the future class, to the future classes. Right? Today we will understand only about this, because this will not make any sense if I start taking it now, because these are the prerequisites. To understand this, first of all, we need to understand the concept of polymorphism, inheritance, and interfaces. Right? Then we will be able to understand the user-defined data types and the typecasting and the conversion. Right? So this will be postponed. We will discuss it in the future. So the definition is very simple. The process of converting the one data type to another data type is called as what? Typecasting. Right? And we are going to discuss about the typecasting on top of primitive data type. Now listen here. Right? When I say primitive data types, and again, I have already given you a chart, if you remember or not. Right? So this is the chart, right? So byte is the smallest data type under the integer data type category, followed by short. And we have integer, and we have long, and we have float, we have double, right? And this is the promotion chart. We'll explain you what is this sometime. So the place holder for the position for the character is below the integer, right? So when we talk about sizes, byte is going to consume 1 byte of memory, short is going to consume 2 byte of memory, and integer is going to consume 4 bytes of memory. This is going to consume 8 byte of memory, and again float is going to consume 4 byte of memory. Double is going to consume 8 byte of memory, right? And the character data type is going to consume, and again 2 bytes of memory. So we know these things already. So we have solved a lot of problems. We have converted the actual decimal value to the binary value, and lot of problems has been solved on top of this each and every data type. Yes or no? Yes, right? And so boolean. So boolean is going to be it will represent itself all alone. It will not compare. We cannot compare this boolean data type with this chart representation. So this is just a kind of a standalone, because the size is only 1 bit, right? So it can either represent true or false, right? So it will not participate in the typecasting, as simple as that. Boolean data type will not participate in the typecasting. So these are the data types that will be participated in the typecasting, right? So having said this, so when I say primitive data type, and so this is the exact promotion chart, right? So this concept is called converting the smaller data type to the larger data type. Practically, we are going to see that by looking at this chart, I can conclude that this is the concept of converting a lower data type into a higher one, right? So the above chart, above promotion chart represents the data type, or to be specific, I can say the primitive data type conversion from lower data type to the higher data type. So now the question has to be, right, if you want to ask any question, the question has to be how this typecasting is done internally, or how the typecasting can be made possible by the programmers. Why it is done, we are going to discuss that after understanding this. After understanding the how, right, we will discuss why it is being done, right? So we have to focus on how this could be done, right? This is our this question needs to be answered before even understanding why this has to be done, right? We will understand how now, right? So this is what it is, and this concept is called, this is also called as widening. So in the interview room, there are high chances that you get a question like, what is widening in Java, right? The answer is very simple. The process of, or the mechanism of converting a data type from the lower data type to the higher data type is called typecasting, and this type of conversion is called widening, right? So this is the simple definition, right? And again, there is a note. This type of typecasting is always safer because there will be no data loss. This is what the theory says, right? But I will make you to understand these things with a practical program, right? So let me take this chart. So let me use this chart in the paintbrush, right? You will get much clarity. Please pay some attention here. So this is the chart. And this should be under int. Let's remove this line. Okay. Okay, this is the chart. Byte will be promoted to short, int, long, float, and double. Right. So this is the hierarchy, and if you look at this hierarchy, right, the question is even the integer. So I think we have discussed this already. If you look at this, if you assume the sizes, right? So the long data type is going to consume 8 bytes of memory. 8 byte of memory, but the float data type is just consuming 4 byte of memory. Right? But when you talk about promotion, or when you talk about the superiority, right? So float is always superior to long. Float is always superior to long. How this can be true? How this can be true? Because float is consuming only 4 byte of memory, whereas the long is consuming 8 byte of memory. I am saying that when you do the promotion, this long can be converted to the float data type. Right? When I talk about the superiority, so this float is somewhat higher than the long data type. How this can be true? The example is very simple, even though we have discussed this in our previous classes. For the new case, I am explaining this. Right? For example, let us say that there are two persons. Person A, P1, P2. Person 1, person 2. Right? Person A is 30-year-old, and the person B is 60-year-old. 30-year-old and 60-year-old. Right? So both, when they check their weights, so both are weighing 80 kgs. 80 kgs. Right? Can I say that by looking at the weight, so both are going to have the same experience, or both are going to, can I just come to a conclusion just by looking at the weight? Person 1 is weighing 80 kg, and the person 2 is also weighing 80 kg. By looking at the weight, can I say that both person are going to be in the same age category? No, it is not possible, right? We cannot come to a conclusion just by looking at the weight. What we usually do, we will compare the ages. By age, we will define, or we will assume, or we can rewrite their superiority with the ages. Right? Likewise, we cannot come to a conclusion just by looking at the size or the size conception. Right? So this float is capable of handling both integer value as well as the floating point value. Even though it is consuming only 4 bytes, it is capable of handling both kind of data. It can be floating point data, or it can be the plain integer data. Right? That's why it is superior to long data type. This is superior to long data type because of this. Right? And followed by the double. Double is consuming 8 bytes. So no issues with the double. So actually the confusion starts why the chart is defined like this, why the chart is outlined like this. Right? Because float is just of 4 bytes and long is of 8 bytes. So it is consuming more amount of memory. So this long data type should be placed here. But why it is placed before the float data type? This is the answer. This is the answer, because it is capable of handling both kind of data, and that's why we call it as it is superior to long data type, even though the memory consumption is somewhat less than the long data type. Right? Making sense? Just type yes in the chat box if you understood this concept. Yeah. So you will have to remember this chart every time. Right? You will have to remember this chart. And one more thing, the point to be noted here is boolean data type will never be participated in the typecasting. It is not going to be participated in the typecasting. Boolean data type. It is going to stand separate. It is like I am unique. Do not compare me with yourself. right? It is representing only true or false, right? But all the numerical values, all the integer values can be represented by byte, short, int, long, float, double, and even character as well. We have seen these things, we have discussed these things in the previous classes. All integer values can be represented by these all data types. That's why the conversion is possible between these types, but we cannot include boolean data type. A very straightforward conclusion. Right, now let us understand the concept. Right, so this diagram or this outline talks about the data type conversion from lower data type to the higher data type. Right, so let me draw another outline here. Right, I have a byte, and the byte is going to get promoted to what? Short, and short is going to get promoted to integer. I mean, I'm talking about the possibility. Integer can be promoted to long, long can be promoted to float, float can be promoted to double data type. Likewise, the character is going to be promoted directly to integer. This character has nothing to do with this byte or short. You will get incompatibility issues. If I say incompatibility issues, it is like you cannot convert byte to character, you cannot convert short to character, and vice versa. This is not possible in Java. If you ever have to convert the character data type to any other data type, right, the flow has to be like this. Like what? This is how the flow should be. Character can be converted like this, promoted like this. It can be promoted to integer, long, float, double, but not short or byte, not in the reverse direction. Likewise, this is one way of understanding this. Right? And if you take byte, so byte can be promoted to short, int, long, float, and double, but not byte has nothing to do with this character. This flow is disabled by Java. Hope you're able to follow me. Right? So in other words, the typecasting, when I talk about converting lower to higher, just remember this line. This path is possible and this path is possible. Right? There is no such path like this or like this. Character cannot be converted back to short byte, or else byte cannot be converted. I mean, byte can be converted to short, and but short cannot be converted to character. This path is not there, I mean to say. So forget about this path. There is no this path or this path. Making sense? Right. So let me give you a small example for the better understanding. Right. The theory part is over. So the practical implementation can be like this. When I say byte b equal to, let us say that a simple example 10, short c equal to, now you must understand one thing, I am using the short data type and I am preferring the variable name as c. When I say typecasting, when I say the widening, when I say the conversion between conversion from smaller data type to the larger data type, so this is what I mean. If I do this, if I am assigning the variable which is sitting on top of the byte data type, if I am assigning this variable directly to the short data type, this is called the typical typecasting. Making sense? If I print System.out.println, so I have just teaching you about how this is happening. Why we need to do this, we will discuss that in the future topics. We will understand how this can be done. Okay. When I do print b, first line, and in the second line when I do print c, right, the output is going to be what? Java C space test.java compilation Java space 1010. Right, the value of b is, value 10 is assigned to b. So when you print B, the output is going to be 10, right? And we are trying to print C. And again for C, C is a variable which is taking the value B itself, right? So again the B is assigned to 10, right? So this is also going to be 10. So when you access C, the output is going to be 10. By these two set of instructions, by these two lines, I can say that the value B is getting converted to, the byte is getting converted to short. The byte data type is getting converted to short. It is just like this, guys. Let me go back to the diagram. I have assigned the value 10 to the byte data type, right? After this, I am trying to assign the same value to the short data type. I am assigning the same value is being assigned to short data type, right? This is called what? Converting from byte to short, right? I can do like this also, no issues. When I if I say this, it's also like I can do like this, right? But this is not the concept of typecasting. This is not the concept of typecasting. But when I say typecasting, why can't I use the same value that was assigned to the assigned to one data type? Why can't I use the same value and reassign it to the another data type? This concept is talking about what the typecasting, as simple as that. Both are going to give the same answers. Do you think it is going to give us different answers? No, same answers will be given. But the idea here is I am using the same value and I am reassigning it to the higher data type. That is the idea here. So this concept is called what? Typecasting. This is called widening, because conversion from lower data type to higher data type. Example, the value 10, it was previously assigned on top of byte data type, right? And in the second line, this value again is getting reassigned to what? Short data type. If I keep going like this process is called what? Widening, right? This process is called widening, right? So what are the things that is going to happen internally that we are going to understand now? Let me take let us trace this for the better understanding. So this is our diagram. It will look usually it looks very simple to observe, but these are a little complicated. We make a lot of mistakes, so I need your attention here. Okay. So byte B. So let us do this. The first line is byte B equal to 10, right? So internally 1 byte of memory will be allocated, right? So we have seen these things in the bit manipulations. I request you to visit those videos once again, right? So 8 bits of memory will be allocated. 1 2 3 4 5 6 7, right? So 10 is a decimal number. Internally 10 has to get converted to the binary number. The equivalent binary number is 1010. Everything will be 0, right? So this is what? B, right? The second line, this line says, so the value of B should be reassigned to the variable C, which is of short data type, right? And again, when I say short data type, right, it is of 16 bits, 8 bits, and we need to take another 8 bits. This is what? The short data type. New guys, if you are getting confused, revise the bit manipulation topic. There is a topic called bit manipulations. I have uploaded those videos. You will get a clear picture about this bit manipulations, right? So C, right, the same values will be copied to the short, and the remaining bits is going to be 0. Right? So this is what we call it as converting the lower data type to the higher data type. These are the things that will be happening internally. Converting the lower data type to the higher data type. Right? This is the conversion. Right? So this is short. This is representing short, and sorry, this is representing byte, and this is representing short. Right? If you convert this again, you will get the value 10 itself. All the binary numbers, if you convert it to the equal decimal number, you will be getting 10 itself. But internally, the size of the memory is getting increased. As simple as that. Right? Why these things are being done, why the typecasting concept actually came into the picture is, sometimes this b value is going to exceed the range. For example, today the value of b is 10. Right? Tomorrow, after some changes, the value may get incremented to 20. Day after tomorrow, 30. It keeps it keeps getting increment. At one point of time, what happens? It's going to exceed its limit. It is going to exceed its limit. Right? In those cases, we can use the concept of typecasting. We will just reassign these values to the new data type, and we will be using the new data type. Yes. Let us look into another example. You just tell me if it is possible or not possible. As simple as that. Okay, I will just write it here. Just tell me it is possible or not possible. Taking integer data type a equal to 100, float b equal to. Look at the chart and tell me compilation error or possible. This is the concept of typecasting. I mean, converting the lower data type to higher data type. Is it possible or not possible? Just answer me that. If it's not possible, we get compilation error. If it is possible, we don't get any compilation error. We will see a lot of examples, but I want to ensure that you are getting this topic. Ganesh, Ashwant, Samyukta, Jyoti 1, Jyoti 2, Chaitanya, Raji. No, you will not get any answer, guys. Possible or not possible? Why no answer will be printed in the console? Because I am not using any System.out.println statement. Right? So let me take this example once again. So this is the chart. Yes or no? This is the chart. Byte, short, integer, long. Right? Our example is, this is the example. Integer, so 100, value of integer is given as 100. So on top of integer, value is 100. Right? I am trying to assign this integer value to the float, which means it is going to be from integer to long and float. This is possible, right? Look at the direction. But if it is traveling towards the right, it means it is converting from lower type to higher data type. Possible, no? Integer is here, and because of this float, so we are just converting this to the float. Means if you look at the direction is syncing with the outline, right? It is traveling in the same direction which we have defined, right? Integer to float. Making sense? Another example I will give you. Let me run this. No compilation, it is possible. Okay. Now you tell me it's possible or not possible. Tell me possible or not possible. You just type it now, possible. Okay, possible. Okay, possible. Why possible? The same 100 is being converted to double. And you just look at the direction. Just go with the direction. This is in long flow double. So in this direction, it is matching with the direction that is defined. So possible. Now you tell me. Right. Think and tell me. Possible or not possible? Possible. I want answers from everyone. Possible. Possible. Yes, possible. Very straightforward. There is nothing to be here. So byte data type is assigned with the value and read, right? And the so this is direction. Possible. Possible. Yes. Now you tell me. Possible or not possible? Why not possible, Ganesh? Chaitanya, we get compile time error. Samyukta, Raji, range. Yes, correct. Correct. Correct, correct. Like the answer should be typically like compile time error. Compile time error. So possibly lossy conversion, because when you look at the range for the specific data type, byte data type is going to, at maximum it can store up to 127, right? So here the value 300 is assigned to the byte data type. So 300 is not a possible value, it is out of range. It cannot handle this, right? That's why not possible. Right now you tell me 20 character. Possible or compile time error? Not possible. Are you saying possible? When I says not possible, distinct answers. Samyukta has just delivered the answer not possible just now. Okay. What about others? Jyoti, Raji, who are they? Response is not responding. Ganesh is error. Okay, let us see this. Saving. Compile time error. We get compatibility issues. I will tell you why. Because when I was when I was outlining this diagram, I said it very clearly, right? So this flow is not possible. This flow is not possible, right? Let us go back to the program. So byte a equal to 20. So 20 was assigned on top of byte, right? If you look at the way it is going to travel, byte can be promoted to short, can be int. This is the path. This is the path. When you do promotion, this is the path. The path cannot be like this. This path is not defined in Java. Byte, short, and char. This path is not defined. That's why compatibility issue. This is not possible. This is the only one direction for byte. When you start from byte, the byte should end at what? This is the starting point for the byte. While doing the promotion, right, it should end at here. Means the direction is very straight road. And again, if you're starting at the character, for the character, this is the direction, right? There is no direction defined in between byte and the short. This is not possible. Making sense? Just type something in the chat box. Clear? Yes. This is the promotion chart. Remember this promotion chart. It will be very helpful, right? And few more example we'll discuss. character b equal to a. Double b equal to b. Possible or not possible? It is. That is one. Possible. Chaitanya says error. Ganesh is possible. I am waiting for answers from Samyukta, Shashwant. Possible. Possible. Definitely it is going to be possible, guys. Right? So firstly, so let us bring this here. Let us run this. So now we are just talking about the possibility. Internal things we will talk. We will discuss. Good. So no errors. It is possible. What is happening here? This is the print screen. So this is the program. This is the program. And just look at the conversion. Value A. A is in the form of character, single character or single letter. Right? So single letter is assigned on top of character data type. Right? It is satisfying the conversion chart. A, which is of character type, is being promoted to double. Right? The path is fine. The path is fine. When you talk about possibility, possible. But what value will be displayed when we try to access this, that we will discuss. When you talk about possibility, it is completely possible. Making sense? Chaitanya? Yeah. So we are now good at the possibility scenarios, right? And let us do this. Float. Now tell me possible or not possible. This is popular interview question. You believe it or not? Possible or not possible? Everyone answer. Jyoti. There are two Jyotis. Samikta, Shashwant, Raji, Ganesh. Jyoti says possible. Samikta says not possible. Ganesh says not possible. The people who are saying not possible, can you also tell me the reason? Any reason for the... Yeah, Ganesh, you are good. Yes. F is missing. Correct. Correct. Because if I do the compilation, right, the incompatible types, because when a value is getting assigned to the float data type, we have to ensure that the value is suffixed with F. This has nothing to do with the promotion. Of course, it has to do with the promotion. Before even thinking about the promotion, first of all, we need to focus on the value, whether the value is compatible or falling within the range, or it is defined correctly or not. When you use float, it is your duty to also suffix the value with F. Making sense? Now this is possible. So no compile time error. Okay. So another example. This is the interview question. This one. This one is interview question. It looks very simple and clear, but this is how you may get this kind of question. Float is there. Next thing is, I'm taking integer. Integer 100. Character C equal to. Tell me, this is the last question. Possible or not possible? Ganesh says not possible. Good. Not possible. Not possible. I hope you understood the concept. Yes, it's not possible because the direction is going to be in the reverse way, right? It is just like traveling in the reverse direction. Very simple, right? The value 100 is assigned on top of integer data type. I'm trying to promote it to character data type. In the reverse direction. Reverse direction is always not possible. Only forward direction. Right? Now you tell me double b equal to 100.00. Load c equal to b. Possible or not possible? Last question before moving to the next topic. Not possible. Not possible. Correct. Exactly. Backward direction. Yeah, you got it. You got it. You all got it. Good, good, good. Possibly logic conversion. Double to float. It is saying double to float is not possible. Try to do the recorrection. Compiler is very clever, isn't it? Okay. So the theory says, right, primitive data type, under primitive data type, we have completed exactly. Okay, one more example. This is also a typical interview question, but the question is not as straightforward as that I am going to give. Boolean c equal to, not boolean, character, we take integer only, integer a equal to, okay, byte b equal to 100, boolean c equal to 2. Byte b equal to 1, boolean c equal to b, system.out.println. What is the possible answer? Possible answer is not possible. Hey everyone, even before even typing, I have found these answers. Not possible. Compile time error. Okay. Possible. Okay, both compile time error. Yes. Because Boolean data type has nothing to do with the typecasting. It will not participate in the typecasting. It is unique. Will stay all alone. Like it is not happy, or it is not defined to be compared with these data types, the conversion data types. The conclusion. The conclusion is very simple. Under primitive data types, right, we have a concept of the promotion chart, right? And if you do the conversion from lower data type to higher data type, so this concept is called as widening. Right? Widening is very simple to understand now. Right? And again, there are few points that can be added. It is also known as implicit conversion. Remember these terminologies. Implicit conversion, or it is also called as casting down. So it is safe. It is always safe because there is no data loss. When I want to justify this line, I am saying that this type of typecasting is always safe. There is no data loss, right? When I am writing a line in such a way that, what do you exactly I mean by this? Right? Simple example. When I say byte b equal to 100, integer c equal to b. Right? This 100 is going to remain same. The value of 100 will never get manipulated. That's what I mean. There will be no data loss. But there are some cases for the downcasting, there will be data loss that we are going to discuss now. Right? When I do this, if I run the output, the value will be preserved 100 itself. No matter what, if it is int or if it is a long, right, the exact value is going to be preserved. 100 will remain as 100 itself. Right? I don't think any discussion is needed. Double. Hundred. Float. Hundred. Do you see any changes? Any changes to the value? Right? Hope it is making sense. Is talking about what? The safety of the value. The value will never get manipulated. Same value is going to be there forever for all the typecasting. Right? Okay, this point is done. Primitive data type, and we are talking about the widening. Now, second concept is we have a concept of narrowing. Right? Concept of narrowing. This is the first concept. Data type, widening, typecasting. Second concept is narrowing. So I need more attention from you to understand this narrowing typecasting. Narrowing typecasting. So the promotion, it is talking about it is not going to talk about the promotion. It is going to talk about the depromotion. Means just the opposite. Converting from higher data type to the lower data type. This is talking about converting a value or converting a data from its lower type to the higher type. That is called as widening. We are just widening it. We are giving a lot of space. If you see the memory evaluation, right, the same value is getting a lot of space. The byte, when the byte is being converted to short, right, this value 10 is going to have a lot of sufficient space for widening. The memory is going to get widened. Right, but when you talk about the narrowing concept, the memory is going to get what? Shelved, or the memory is going to get decreased or compressed, I can say. This is the first takeaway, first bottom line. So the simple expression is this is a mechanism of converting the higher data type to the lower data type. So this is known as the explicit typecasting. Explicit typecasting, and we can also call it as casting out. Casting out. Example, same thing, we will do these things in the reverse order. Right? Double. So double gets depromoted to float, and float gets depromoted to what? Long. Long gets depromoted to what? Int. Short, and we have byte, right? And over here, the integer gets depromoted to cap. Making sense? Same thing. So this is talking about promotion, this is talking about depromotion. Right? When you do anything I am missing, long into flow chart, okay. And again here also the boolean will be unique. Boolean will not participate in both the cases. Right? So here the point to be noted is previously this type of typecasting is always safer because there will be no data loss. But in this case, this type of typecasting is not safer, just opposite, because there will be a data loss. Very simple example. Let us take a very small example now to understand this better. Okay. So now you tell me, now you like by looking at this theory, it's called as explicit typecasting. Explicit means something the programmer need to take care. Right? When I do this, integer a equal to, let us say that 170, or not integer, let me keep the example simple. Short b equal to 145. Integer c equal to, not integer, byte. So possible or not possible? We get compile time error, or is it possible, or we get compile time error? This is the latest one. No. Here are not possible. Samyukta, Raji, Jyoti, Chaitanya said Ashwant. Not possible. Not possible. So it is not possible, guys. Yes, it is not possible. But when you look back the theory about the concept of narrowing typecasting, so narrowing typecasting is a mechanism of converting higher data type to the lower data type. Right? So how do we achieve this? When this theory is valid, this should be valid. Yes or no? When this theory is valid, this should be valid. But I need to ensure that the compilation is successful. Also, we are getting some kind of output in the console. Right? Theory says it is possible, but theory also says that this is also known as explicit typecasting. Explicit. We need to do some changes. We need to do some typecasting. Explicit. Previously, it was implicit. Now, explicit means programmer has to take some responsibility to do the typecasting. Very simple. If I want to make this possible, so this B is representing short data type. I need to use a typecaster. So this is the typecasting symbol. Opening bracket and the closing bracket. Right? The data type I am going to use inside has to be compatible with the data type that is assigned to the resultant value. Let me repeat. The data type that I am going to use inside should be compatible with the data type of the resultant value, or the value that is assigned to the resultant data type. Right? So the explicit conversion says, let me use this operator. Right? So I'm using byte in the LHS, right? Left hand side byte. Now you do this. This is called as what? Explicit typecasting. This is possible. Right? If I remove this, not possible. Right? To achieve the explicit typecasting, or to achieve the narrowing, the programmer has to take care of the typecasting. So you need to convert. I mean, this short needs to be converted to byte. For that, you will be using, this operator, typecasting operator. Inside this, you will assign the value of the resultant data. Making sense? Yes or no? Okay, let me run this. It will look little difficult. Trust me. After few examples, you will get this completely. Okay, let me run this. Compilation is successful. So we get a value minus 11. Forget about the value. Data loss. Value is not the expected one. Data loss. Why data loss? I will explain you. But for now, right? So compilation is successful. We have achieved two things. Compilation is successful, and what? Compilation is successful, and results has been displayed in the console. Means execution is successful. But however, there is a data loss. Right? So actual value is 145. When you do the downcasting, right, the data has been converted to a different data, minus 111. Minus 111 is not even close to the actual value 145. Yes or no? We go minus 111. So if you go back to the theory, I will tell you why we got minus 111, but try to understand the topic. The mechanism of converting from higher to lower. So this is justified. This is known as explicit typecasting. Why explicit typecasting? You as a developer, programmer, needs to do some changes so that this will be compiled and executed successfully. That's why it is called as explicit. The third point, it is also called as casting up, because this lower data type is going to be casted up to the upper data type. That's why casting up. So this is the chart. This is the chart to ensure that this chart is getting justified.